Hello everyone, welcome back to the Web Security channel. In this video, I'll show you how to use a union-based SQL injection attack to retrieve data from other tables in a database. We'll be working through the PortSwigger lab titled SQL Injection Union Attack, Retrieving Data from Other Tables. In my previous tutorials, I explained how to determine the number of columns returned by a query and how to identify which columns can hold text values. Now we're going to build on that foundation and use those skills to extract data from another table, so if you've been following along, you're ready for this. If you missed the earlier videos, I've linked them in the description below. Before we begin, a quick reminder about ethics. This video is for educational purposes and authorized testing only. Do not attempt to use these methods on systems without explicit permission. In this lab, we'll be working with a vulnerable product category filter that's part of a simple online shop. The way this filter is implemented allows user input to be inserted directly into a SQL query without proper sanitization. That means the application is unintentionally exposing part of its database through a SQL injection flaw. For this exercise, my objective is to use what we've already learned, determining column counts and finding columns that accept text, to perform a union-based SQL injection. The goal is to retrieve information from another table in the database, specifically the user's table. Once we extract the usernames and passwords stored there, we'll use the administrator's credentials to log in and complete the lab. I'll be using a few test payloads. Single quote union select null -- helps determine the number of columns. Single quote union select abc -- helps identify which columns accept text values. And single quote union select username, password from users -- is used to extract data from another table. We're opening the lab and starting our testing. First, I'll click on one of the category filters, in my case, it's pets. I'll add a single quote to the category parameter to check whether it's vulnerable to SQL injection. The response returns an internal server error, which confirms the input is not being handled safely. To determine the number of columns, I'll add +union +select +null -- and send the request. As you can see, we still get an internal server error, so I'll continue testing. Next, I'll add a second null separated by a comma and send the request again. This time, the page loads normally, which tells us that the underlying query returns 2 columns. The next step is to determine the data types these columns accept. I'll replace the first null with ABC and send the request. The page loads without errors, and we can see the value I entered. Now let's check whether the second column also accepts a text value. I'll replace the second null with def and send the request. The page loads normally again, which means both columns accept text values. If you look closely at the page, you'll notice a title and some text. These correspond to the 2 columns the query returns. Let's scroll and find the test values I used, and there they are displayed at the end of the page. We'll use these 2 text-compatible columns to retrieve data from another table. I'll enter the payload single quote union select username password from users -- and send the request. You'll notice I'm using plus instead of spaces. That's because the query is URL encoded, and in this URL format, spaces are represented by plus signs. Now look carefully at the page. You can see that usernames and passwords from the user's table have appeared. To complete the lab, we need to log in as the administrator user. Find the administrator entry, copy the password, and go to the login page. Enter administrator, paste the password, and click login. And that's it, we're now logged in as the administrator, and we can see the message confirming that the lab has been successfully completed. Let's take a moment to understand what's happening behind the scenes. When we select a category on the website, the value we choose is inserted directly into a SQL query on the server. Because this input isn't properly sanitized, we can modify the query by adding our own SQL code. The union select keyword allows us to attach a second query to the original one. But for this to work, our injected query has to match the structure of the original, specifically the number of columns and the data types in those columns. Once everything matches, the database combines the original results with the data from our injected query and sends it back to the application. The then displays that data as if it were normal content. That's why we're able to make usernames and passwords appear on the page. In the next video, we'll continue working with union-based injections and learn how to extract multiple values even when the application returns only a single column. Thanks for watching. If you found this video helpful, be sure to like and subscribe for more beginner-friendly content on cybersecurity and ethical hacking. And don't forget to check the video description for all the links I mentioned. If you have any questions or suggestions, please write them in the comments. See you in the next one.